Hi there, I'm Phil from PicoKit. Today we're going to have a look at how to drive a servo motor using the Pico Mini driver. So first of all, please make sure that you have the 14-pin analog for the Pico Mini driver or the 20-pin analog for the Pico driver. We're going to do this using the servo tool, which is a nice easy tool to use and can be used in a couple of different ways. So let's just have a look at how to do this. What's happening here is we have two options. We can either send a literal or a file. Now, a literal just means a set value. You might have it set to a particular angle, okay? Which is a nice way of doing things. A file would be like if you wanted to drive it off a bit of feedback to say, okay, you've got a little potentiometer or rotary encoder and you want to be able to turn it, and it turns your servo motor to a desired angle or calculated off whatever that is that you're setting. Today we're going to have a look at the literal, and to do this is like setting a few limit switches with the motor, but a little bit easier, as you'll see. Okay, so if we set 300 and C0 is our pin, put in a delay tool, and because between servo pulses you actually need to send what's called a servo delay of 18 milliseconds. You can sometimes change that depending on what other tools you have in there. Okay, so if you have a bunch of other tools between servo operations, you might need to change that millisecond to get the pulses to send correctly. But as it is there, that's what we need to be able to program a servo motor. There we go. So that's set the motor to a particular position, and that position we get from our literal, we put in a position of 300. In fact, if we go to our minimum, which is 0, not all servos can achieve 0, but there it is there. Not quite, this hasn't been set up so that's quite at the right angle. And you'll notice with servos, if I push on that, that provides some force feedback. It actually wants to stay where it is, which makes a servo motor very good for operation. But as you'll see, it is drawing more power than it should through this USB, even though the batteries are on. And that just shows you that it is drawing quite a lot of power to maintain its position. But it's also not as scalable as if you were just using DC motor or even a stepper motor, in that you can drive some larger motors with larger voltages on the Pico Mini driver. These ones you are determined by the power supply, and we're running 6 volts in this power supply. Mind you, if you had an actual 6-volt power supply and power outlet, then you could hook that up and you would have no trouble with providing enough current to drive that sort of a motor. So let's have a look at that. We can define a minimum position and a maximum. So we'll just call this min. Oh, if I can spell that right. Min, and say the minimum position is it's out of 1600, so 400 is a quarter of the way. So let's do that. Okay, so that's our minimum 400 position. Hear it sort of chattering away there. It's not quite set. There it is. Gets to a point, if it doesn't have enough power, it doesn't quite get there. So it really does need to be run off. Maybe these batteries are going a bit flat. Okay, so if we go here to max, say we set this at 1200. Okay, and so what we might do with that, instead of going straight back, we can't move on. We do have to repeat min a certain amount of times before it moves on. So but we can copy that delay because that's our 18 millisecond delay, and so we put those two together. We can also repeat that for as many times as we want before it moves back. So if we repeat that, it's about 20 milliseconds in total. So we can calculate if you're doing 50 repetitions, you should hold that position for about a second. Okay, so I could even label that as 1 second, even though it's just counting 50 repetitions. But after 1 second, it's going to move on, and we could do the same thing. Get a bit of a washing machine action here. Let's put the true on top. Here it is, and do that. Okay, and so we've got our minimum for a second, our maximum for a second. Let's program. Okay, and you'll see it's moving roughly 90 degrees there. Okay, so between the minimum and maximum position. So that's a nice way of defining if you're doing a simulation of a model, like a boom gate or something for a train, or you know, you can go up or down, and it knows when it's got to its limits, and you can define those limits in the code. So you don't need extra switches. So it means it's nice and easy that you're just hooking up one cable, plugs straight in, and you can get that simulation happening nice and easily. Also useful for robotic arms and such. But that's how to use a servo with the Pico Mini driver. Thanks for watching.